Awesome.
Yeah, hello everyone. I welcome all on Data Phoenix webinar. Today we will talk about LMs and their evaluations, how you can evaluate it. And with us, Saurabh, he is a founder and CEO of UpTrain. These startups participate in Y Combinator, and he will talk about how you can do evaluation of LMs and how you can use him solution for this work. Um, you can ask the question using Slander. The link is under the video. So please ask the question, and after the presentation, we will answer for all your questions. I give your microphone, Sarah, your stage.
Yeah, thanks a lot for hosting me, and really excited to talk about what we are building at UpTrain, and also cover the broader topic of how to evaluate LLM responses. Just to introduce myself. So myself, Saurabh. I have been building machine learning models for the last 8 years. I started my journey at Goldman Sachs, built machine learning models for finance, then switched to the self-driving car domains. So I was a deep learning consultant at Bosch Universities, building computer vision modules for understanding scene, pedestrian detection, and so on. And then did my own startup, which was called Insane AI. It was an AI-powered fitness app. Taking inspirations and taking learnings from my past experience, I decided to build UpTrain. We are an open source LLM application evaluation tool. So essentially, we help to evaluate the quality of your LLM responses and how suited are they for the particular use case which you are serving. I'll talk more about UpTrain, as we dive deeper into this presentation. And as it was mentioned, like we were part of the recently concluded Y Combinator batch. So without further ado, let me quickly, introduce the agenda here. So, I mean, everyone here knows that, like LLMs have really captured the world. ChatGPT was launched, towards end of last year, and it just went viral within days. So within just 2 months, it gained more than 100 million users, something, which other even like highly successful softwares like Facebook or Instagrams took many years to reach that milestone. And it's like these LLMs are super powerful, and they're really transforming the way we compute with computers or we compute with any of the electronic devices. If you think, like even like something like 5 years back, like the mode of communication between us and the machine was through very structured data. We would get instructions, either, it could be textual instruction in forms of code, or we would hit certain buttons. But the way we would communicate with these electronic devices was highly structured. But now with the advent of LLMs, we can communicate with them with just language. I can, type a single language query to my computer, and using the power of ChatGPT or using the power of LLMs, it can give me a very appropriate response of what I'm asking. I no longer have to learn the lingo which my electronic device or my computer understands. And these LLMs, they are able to understand the context, they are able to understand the intent behind the question which the user is asking, and finally they are able to generate human like responses. So studies have shown that the response, people are not able to distinguish between the response of an LLM versus the response of a human. And this led to many use cases, things like voice assistants, chat bots, automated content creation, like writing marketing pieces with the help of these LLMs, generating code with the help of these LLMs. Like, Codex is a very famous example of an LLM which helps you with the same. People are using LLMs to convert simple text into SQL queries, which can later execute and give them data analytics and so on. So this is, just, I guess all of us already know this, but this is just to kind of set the context of, how important these LLMs are and, what the impact they are making on our life. Now, one interesting thing to consider here is that these large language models, they are a little different from the classical ML or the deep learning models which we have dealt earlier. If you think about, any of the machine learning system, be it deep learning, be it classical model, be it XGBoost, be it CNNs and so on, you would see like the bread and butter of that whole infrastructure has been that, you have a testing data set. So you will, have a golden testing samples. You will run the model. You have two versions of the model. One which is in the production. Second is, it's a different architecture, or you retrain the model. It's a modification of what you already have, and then you will evaluate this model on this testing data set. You will get a quantitative measure to compare the responses. It could be precision, recall, accuracy, hit rate, and so on. And then based on that, you will make a judgment call whether the new model is better for your application, or you should continue with the older model, or experiment with some other architectures and so on. But now, as we come to the world of LLMs, this paradigm is breaking. One of the unique things about LLMs is that they lack a unique ground truth which you can use for comparison. For example, if you're using GPT-4 to write an email to a candidate asking for his or her confirmation for a technical interview, there is no right email. There is no, like saying that, okay, this is what the LLM should generate, and you can compare it word to word. You need a human to read through the text and make a judgment whether the new response is it good or not, whether it's appropriate or not. And this presents a very big problem, right? Because now every time you have to judge the quality of your application, you have to do this manually. You have to spend a lot of human efforts in order to say whether the new change is making sense or not. So this is the topic, which we will be covering in today's presentation, where we will try to understand, what is the importance of these evaluations, what are the criteria for these evaluations, and then we will walk through in terms of, what are some of the methodologies which you can use today to reduce all these manual efforts and have a more systematic and quantitative way to evaluate your models. Like uh, to no one's surprise, this is a very active area for research. A lot of papers, a lot of contributions from the community is happening almost every day, where people are coming up with novel techniques and they're coming up with new methods to evaluate the performance of their large language model based applications. Before we go into, like how to evaluate this model, let's just first understand why this is necessary. Why are we even talking about LLM evaluation? Firstly, as I mentioned earlier, if you are experimenting with multiple prompts, if you are experimenting with multiple model providers, having a robust evaluation pipeline helps you to make quantitative comparisons between your original model and the new model. You no longer have to just manually skim through the responses. You can generate, if you have a robust evaluation, you can generate some numbers, you can generate some metrics, and make a judgment call based on that, on terms of, which prompt is working better for your use case. Secondly, you to deploy once it's working on live user data. In presence of an evaluation framework combined with activity, it will help you to identify it will help you to understand, this is where well, this is to improve experience working with that naturally contributes to the more I develop, as part of my offerings. You want your users against incorrect, or hallucinated responses, and robust evaluations, your model before showing it to the end users. It can help you to validate whether these responses are correct or not, and it can safeguard your users against such incorrect values, and as a result, build more trust, build more credibility for your offerings in terms of your users' minds. Finally, as all of you might know, these LLMs are ever changing. OpenAI keeps on releasing new models. It keeps on updating these models. In fact, a recent research has shown that there have been instances of model degradations. The GPT-4 model's response quality is degrading over time, and having a robust evaluation pipeline, it can enable you to run regular regression tests. It can enable you to like compare the performance of your model week on week and make sure that you protect your applications against such performance degradations. So, let's just see, what we mean by evaluations with an example. So in this case, I'm just asking GPT to write an email to a candidate called Saurabh, asking write an email, where the agenda is that you want to take the confirmation of the candidate for a technical interview on, at 8 p.m. 22nd of July at Starbucks. So this is the response I get, like, dear Saurabh, hope this email finds you well. We have want to confirm your scheduled technical interview. We were very impressed by your qualifications. If you want to reschedule, reach out to us, etc., etc. So if you read through this email response, you will see that, as a human, if I evaluate it, I see there are couple of issues. Firstly, if like when I asked the my LLM to write this email, I just mentioned 8 p.m. I never said it's 8 p.m. Pacific time. So the model has made up a time zone which was not present in your initial prompt. So it has added some unnecessary information which could be wrong in this case, and hence this, if I use my LLMs to just create this response and send it to the users, it could lead to incorrect outcomes because the users might be confused in terms of the timings of this interview. Secondly, if I read the second paragraph here, we are seeing, if I just read it out, like, we were impressed by your qualifications and experience, and we believe you could be an excellent fit for the technical role we have available. And during the interview, we will discuss your technical skills and problem solving abilities and potential contributions also to our team. So as you see, like reading this whole sentence, there are a lot of ands, and this whole sentence is little hard to read. It's not very fluent. It's not very easy to understand. It's not very easy to read. Thirdly, if I look at the next paragraph where like the email writes that if you want to reschedule, it would be better that you contact me via email or phone at some phone number exclamation mark. So firstly, the phone number is made up, right? There was no mention of the phone number in the original prompt. And secondly, this is not like a polite way of saying things, right? Like if you read the sentence, it's written in a sort of a rude way. Definitely something which you don't want to send to a potential hire. Like you don't want to send uh, like instructions with an exclamation mark because that's not a polite way of saying things. So, as a human, we can understand that, okay, there are certain issues with my model. There are certain issues with the response I'm getting from my model. So now let's think about, how can we evaluate these LLMs? How can we evaluate the output of these models so that we don't need to rely just on, a very manual human feedback, a very manual human response. So, if I look at the same example, if I define something called a hallucinations count, so essentially, like how many times my model is making some information which is not present originally. So I can see that in my original email, in my original prompt, uh, anything like, time zone was not mentioned. So that's first count of hallucination. Secondly, phone number was not mentioned. So that's second count of hallucination. So I can extract relevant information from my response and I can compare whether this information is present in my original prompt or not. And if it is not, then my model is hallucinating. Similarly, I read the second paragraph. I can give it a coherence score. So I can say that, out of 100, since the coherence is low, I will give it a score of 24. So I can quantify how well the language quality of my response is. Thirdly, like since the output is not very polite, I can also score. So in this case, I'm saying that, I'm giving a politeness score of, sorry, a politeness score of 63 out of 100. which essentially means that the output of my model is not very polite, and I am able to quantify this. So as we see, using such a evaluation methodology, using such a framework to evaluate the outputs of my model, I'm able to assign scores for certain attributes. And now if I can do this for all the responses which I'm getting, I can easily do prompt testing. I can easily make sure that whenever the coherence score or whenever the politeness score is less than 50 out of 100, just give me a new response where there is a higher emphasis on politeness or politeness quality and so on. So talking about like what are these different dimensions on which we want to evaluate these LLMs, like things like hallucinations, things like politeness and so on. So at UpTrain, we have identified, what are some of the key categories in which you want to evaluate your model quality. So the first one is the language quality and the communication score of your model. So this essentially means that, things like, grammar correctness, things like fluency, coherence. It just means that the output is very well written and it is able to communicate very clearly what it is intended to communicate. Secondly, it's adaptability and context awareness. So this represents the well my response is adapting to the prompt which is given. Is it giving some irrelevant information? Is it making up some facts? Is it hallucinating? Is it like if it is extracting some facts, is it coming from the context which is given to the model, or is it coming from some weights which my model learned while training and not really relevant for this use case? Third is the engagement and the appeal. So this essentially touches upon the creativity of your LLMs, like how well the model is written, how likely the user is to respond to them, how creative the response is. So it encompasses like criteria like those. Finally, ethics and biases. So these represents whether my output is racially biased. Is it like is it treating any community, any gender, or any religion unfairly? Does it contain any toxic words which should not be present in the response at the first place, and so on? So these are, like a broad category of these different dimensions. So at UpTrain, we have identified like almost 30 to 40 such dimensions, things like flexibility, expressiveness, informativeness, responsiveness, diversity, likability, toxic keywords, and so on. And we essentially want to evaluate your model on these criteria. We want to give a score for each of these criteria so that you can, if you're writing a storytelling app, you can easily give more weightage to engagement and appeal. You can give more weightage to creativity versus, let's say, you're asking to, like have a very factually correct answers. You're asking your model not to hallucinate. You can give more weightage to the scores which are concerned with context awareness and adaptability. So now, once now that we have identified how, on what dimensions you want to evaluate these LLMs, let's look at some of the methodologies which can be used for the same. Firstly, like we definitely, you want to carry forward what are the matrices which are defined in the traditional NLP space, and try to see if any one of them or some of them are applicable for certain use cases. So, if your LLM is concerned with a machine translation task, so if it is, translating from language A to B, like maybe from English to Spanish, you can use matrices such as Blue, Meteor, or T, like translation edit rate, to quantify the performance of your model. These matrices essentially, compare that how much changes you need to do to convert the given output into the actual ground truth output, which is already annotated. Secondly, for summarization task, where your objective is to summarize a model into a smaller chunk, you can use either rogue metrics or you can use BERT score. Both of them essentially capture on how well the summarized output matches with the actual ground truth. For test generation task, which is little trickier than all the above because there is no good ground truth, you can compare something, you can calculate something called perplexity, which essentially computes on how coherent these words are, which essentially computes that how likely is it that the words which your models have generated, how likely they are to form a meaningful sentence. And finally, if you have a test classification task where you want to classify, let's say classify the intent of a tweet into whether it's good, bad, or neutral, you can look at matrices like accuracy or precision read and recall and so on. But as we see, these matrices driven evaluations are pretty limited because only very specific metrics can be applied for a certain use case, and even then the evaluation is highly limited, and it like there is a lot of assumptions which are being assumed as we are calculating these scores. The second set of evaluation comes from utilizing the embeddings which are generated for these responses as well as the queries. So, I can either compute embeddings for each of the words, and you can do intrinsic evaluation, which essentially compares the how correlated these words are, how correlated what is the cosine distance between word A and word B in terms of their embedding space. You can look at extrinsic evaluation, which essentially means that you want to use the generated embeddings and use it for a downstream task to compute the quality of the embeddings which you have generated, to compute the quality of the text which you have generated in terms of how well they are able to compute the downstream task which has been mentioned. Secondly, you can do the same evaluation. You can compute the same embedding or on a sentence. Uh, On top of it, you can do semantic similarity. You can use cosine distance to find similarity between your query and the answer and see that is my answer really, is my response which is being asked by the user. Secondly, you can use the embedding to compute semantic sentiment analysis. You can compute whether the output of my model is like what is the tonality of it, and you can utilize embeddings to compute the same. Finally, you can also use the embeddings to figure out how contextualized my output is, how well my response fits in this given context with respect to this given query and the given context. You can do things like trying to figure out whether the words are making sense or not. You can identify essential information by named entity recognitions and use it to further compute hallucinations for your model. Thirdly, which I feel is the most interesting one, is because obviously you want to use humans to evaluate the quality of your model, but humans are costly. But fortunately, LLMs can behave like humans, and they're pretty cheap. So as a result, you can in fact use ChatGPT to evaluate ChatGPT response. Now you might ask, this doesn't look very natural because if the model itself is giving me a certain answer, obviously it's going to score that answer really high. So an interesting observation here is that asking an LLM to generate a coherent response, the quality of, the output quality of such a request is not the same of asking LLM to give a coherent score. Like if an LLM is not generating a coherent response for a certain query, it might still be able to give a very high quality coherence score, which you can use to quantify, which you can use to like evaluate your models upon and get more like quantitative metrics for different dimensions such as politeness, coherence, fluency, and so on. This comes with multiple benefits because model grading is standardized. Like you if you're using chat gpt for grading like thousands of responses, you can do that with a single api call, and you will get standardized results because you will be using the same prompt, you will be using the same criteria, and which will promote consistency and objectivity for your use case. Finally, using chain of thought, you can also ask the LLM to not just give a score, but also give a rationale in terms of if the politeness is low, where exactly the score is dipping, and what exactly are the paragraphs which is contributing to a low politeness score for your use case. Finally, human feedback and human evaluations can contribute a lot to evaluate the quality of your model. So you can ask humans to give ratings. So you can ask them to rate a response from like in discrete buckets like 1 to 5 or 1 to 10. You can ask them to give a preference. So if you have like like two responses corresponding to two different prompts, you can ask them to compare and rank which of the two responses looks better to them. Thirdly, you can ask humans to do a parity check. So let's say you have a ground truth for your test cases. You can ask the humans to say, if I compare my ground truth versus the response which is generated by my LLM, like which of them is more likely to be model generated and which of them is more likely to be human generated. And then if the model response is looking more likely human generated, you can say that the performance of a model has improved. Finally, you can do A/B testing, you can do monitoring. So you can incorporate the intrinsic or the extrinsic feedback the users are giving on your app and use them to evaluate the quality of your model, use them to evaluate the quality of your application, use that to compare across multiple prompts and decide which one makes the most sense for your use case. So yeah, this is little bit about how you can evaluate the performance of your LLMs. At UpTrain, we have built a lot of tools. So all the different methodologies which I mentioned earlier, all the different dimensions which I mentioned earlier, we are integrating them. We have integrated them as part of our open source library, so that you can conveniently and easily evaluate your models without having to worry about the underlying methodology behind it. So let me quickly give you a demo of how the uptrain dashboard looks like and how you can utilize them to evaluate the performance of your model. So this is an example where I am using, so this is basically a case where you have sales, you are asking your LLM to act like a sales support agent. So the customer comes with a certain question. LLM has access to some help docs, so it has access to a lot of help articles. So it will query some of these help articles, summarize them, into few bullet points, and then try to answer the question which is asked by the users using this summarized information, using this, extracted bullet points from these help articles. And we are judging how well the model is behaving. For the same, we have defined a lot of criteria. So we have things like summarization quality, right? If you are summarizing some of these help articles, how good the quality of that is. You have knowledge retrieval quality, because the performance of the model depends a lot on how good your vector database search is, how good your embedding search is. So we have defined matrices which help you to evaluate how good is the quality of the knowledge, how good is the quality of the context which you're retrieving. Things like irrelevant information check, so where you want to check if the model is outputting some irrelevant information or not, because if it is outputting some irrelevant information, you don't want it to show to your users. Things like politeness check, you want the response of your customer support bot to be polite. Things like response quality check, like how appropriate this response is it answering the question given by the users or is it giving something else. And you can use all of these checks to compare between multiple prompts. So in this case, I'm running an experiment where I am basically uh, changing how many bullet points I can extract from my help articles, and I'm trying to compare. If I increase it from, in one case, I'm saying that I just need like 3 bullet points, and in second case, I say that okay, I can have more bullet points. I can have 3 to 7 bullet points, and I can get quantitative measures that in one case, 30% of the times we don't have any relevant information, whereas in the second case, the number has improved to 35% of the time. Finally, I can have response quality which has improved from 55% to 66%. So this means that this experiment is giving me a jump of 11% in terms of performance of my model, and I can make a judgment call that this makes sense and I should be productionizing this particular prompt change. Like it also provides you capabilities to drill down into each of these individual checks. So in this case, I can see that how good is the knowledge retrieval quality, and I can see how the two experiments with two different prompts, how are they comparing, what are the areas where experiment one is better, what are the areas where experiment two is better. So we can look at things like if you have irrelevant information, you can, in this case we are asking the model to just give a boolean value whether it has irrelevant information or not, and I can see how many cases have irrelevant information for both the prompts which we have tried upon. So like this is what a robust evaluation pipeline like UpTrain can bring to the table. It can help you to make sure that the changes you make to your model, the improvements you make to your LLM applications, they are properly tested. You have, it's not based on intuition, it's based on quantitative measures, which will help you to quantify the output of your model and make judgments which are not just purely based on intuition but on actual data. Yeah, that's all. Like, happy to answer any questions which our users might have.
Yeah, we have several questions. Maybe before we go to um, the question from our participants, can you describe more how it's possible to use your platform? Because I understand that you show some result, but how to connect and how to take some analytics from LLMs, how it work with
Yeah,
LLMs.
yeah. So actually, let me actually use it, show it with an example. So the way the UpTrain platform works is that you define these checks. So each check here is you give it a name. You define how do you actually compute it. So we have a lot of checks which are already implemented as part of our platform, which can help you define, like help you check for hallucinations, politeness, and so on. So you can just say, I want to evaluate politeness, and you can define how do you want to visualize this information. You can either visualize it with histograms, with line plots, and so on. So once you define your series of checks, so in this case I am defining a list of checks, uh, you like computing accuracies, computing politeness, computing hallucinations, and so on. Once you define this check, you just define your check set, which is a list of checks, as well as a source. A source is the data set on which you want to evaluate. So this is your testing file. So this is a collection of a certain set of prompts, a certain set of testing use cases, on which on which UpTrain will run your model. It will evaluate all these scores and use them to compare across multiple prompts, or use them to do monitoring for you. And then finally you just we provide an API interface. So you register on UpTrain and you just run. So by this, it triggers a run on the UpTrain interface. We internally manage all of the deployments. So we will run on your data set the kind of checks which you have mentioned, and we will give you the results on a dashboard which you can access with your API, the graphs which I shown here earlier. It's a simple interface. You just define whatever you want to, whatever checks you want. You define your data set with an API call. You can call UpTrain to run all the evaluations for you, and at the end of these evaluations, you will be able to see the results on a dashboard, which you can access with the same API key.
Yeah, thank you. So we have several questions. Start from first. How do you calculate the scores?
Yeah.
So you
So
show several scores. How you
that's a great question. So yeah. So essentially, so there like for example, let's say we have a check for politeness score, right? So there are two ways we calculate it. So we basically check for the tonality. We use NLP models to to check the tonality of the model, and then we have built up a small model which kind of calibrates this tonality and uh, like transform into a politeness score. Secondly, we use GPT models themselves to act as evaluators. So, asking GPT that, okay, for a given question, this was my response, and this is the persona which my model was assuming. do you think this is a polite response or not? Like if you can give a score between 1 to 100 in terms of how polite you think this response is, and you can give certain examples. You can do few short prompting to calibrate the score of your model, and you can use the combination of these techniques to get a score and evaluate your models.
Okay. Yeah, we have the one comment about the paper for long text generation. Good paper, they recommend. Okay, thank you. Um,
Thanks.
mm, about performance for GPT-4, that every time when you run it, the performance is downgrading. How would you evaluate such case?
Yeah, great question. So one of the things which we have seen our users, and also like in general we have seen people have started to do in the LLM community, is that they are running regression tests. So if you look at the core of it, like these LLM models, they are non-deterministic. You don't have control over how these models are getting built and how frequently these models are getting updated. Even if you do, your data set is changing, your embeddings are changing, with every single day, new and new information is getting added. So that's why it's critical to run regression test. So you have a test case. Let's say you have selected 1,000 prompts. You have a benchmark of if I run my model on these prompts, last week I get a score of a hallucination score of, let's say, like zero point 0.1 out of 1, which is like only 10% of the cases hallucinated. So week on week, when you run your models, your updated models on the same data set and calculate the same set of metrics, you can track whether the performance of the model is degrading or is it staying constant over time. So that's how you can protect yourself from degradation of the model. So whenever you see if the performance of the model is degrading, probably it's the right time for you to tweak your prompts. It's the right time for you to experiment, let's say, with different providers or experiment with your chains, and make sure that instead of your users complaining about the quality of your application degrading, you can proactively catch them by running regular regression tests on your for your application, like similar to the ones you use for software. Like in the space of software, every week you run some unit test to ascertain that the quality of the software is not degrading. I think with LLMs, a similar paradigm is needed. A similar paradigm needs to be present where you run these models on a held out test data sets week on week and just compare the performance over time.
Um, Good. Yeah, so about presentation, yeah, we publish the presentation after this webinar with the video. Um, Next one, it's more comments, but yeah, about metrics, which depends on different cases.
Mhm.
Uh,
Yeah, and I completely agree with the comment, right? Like most of the NLP matrices which we have defined, like things like rogue score, bird score, blue score, and so on, very true. They can only be useful for very granular tasks. They come with a lot of assumptions, and they can only be used in very like limited use cases. And that's the key issue which we are dealing with today, right? Because these LLMs are interactive at such a level that like it is being deeply integrated in your product. It's been deeply integrated how we are interacting with these machines. As a result, a lot of these NLP matrices are redundant now, and that's why we need to come up with new methods. That's why we need to utilize LLM like techniques like model grading, human evaluation, human feedback, embeddings driven evaluation, and so on, for us to get a better understanding of how good the model is, instead of just relying on standard NLP matrices, which may not be relevant for your use case.
yeah. Oh, sorry. Yeah, and good question about uh, perplexity. So how it's possible to calculate and define it? Yeah, please.
Yeah. So the definition of perplexity, at a high level, it essentially encapsulates that. Let's say I have written a sentence. How likely this sentence is, a meaningful word, like it's a meaningful dictionary, in terms of, let's say, if it's an English sentence, like from an English language perspective, how, like, is this like a meaningful sentence or not? uh, so that's essentially, what perplexity incorporates. So one of the ways you can compute perplexity is that, let's say you have, a sentence like, John is staying at a particular neighborhood, right? So you can just use a model like BERT, or you can use any of these transformer based models, and you can just, like, mask one of the words and just look at the probability of how likely is that word can be filled with whatever is given in your, like, whatever the word is there in your given sentence. Do this for all the words which are present, and, take an aggregation, like, let's say, take an average over it. So you can use this as a way to compute perplexity for your use case, because it is encapsulating, using the knowledge which the transformer have. You can basically, you are determining how likely this sentence can come up in terms of the literature on which the model has been trained upon.
Yeah, thank you. Thank you for this presentation and for showing us your tool. I hope you will growing and have more users, and it's very good that you do it on open source way, and it's open source tool. Um, yeah, thank you for this presentation and sharing your knowledge.
Yeah.
Uh,
Thanks a lot. Like, thanks a lot, everyone. It was, great interacting. You can, like, access our repo at uptrain/AI, uptrain.ai/uptrain. It's an open source repo. You can check it out, and would love to hear your feedback on the same.
And I also invite you to our Slack channel, and we can continue on it to discuss and answer to the question if you will have. So welcome to our Slack channel, and not forget to subscribe to our YouTube channel to participate on our next webinars and see what videos we publish. Yeah, so thank you for all who was with us. See you next week.
Yeah.